let's talk about the law of refraction. It's also known as Snell's law. This is the law of refraction. NA times the sine of theta A equals NB times the sine of theta B. These n's, these are known as the index of refraction. N equals C over V. C is the speed of light. V is how fast light is moving through that particular material. And N is just a unitless constant for that material. So a couple things. C is always going to be greater than or equal to V. That means N is going to be greater than or equal to 1. And in fact, N equals 1 for a vacuum. So if you have a region that's devoid of anything, there's nothing there, and light's moving through it, that's a vacuum. N equals 1 for that situation. Now these angles are measured relative to the normal. So I've got an example over here. See over here. These red lines are the path that the light rays would follow. So for example, I've got light coming in here, and it gets to this interface. So up here, this is material A, and then down here, this is material B. So light comes in, and then it hits the interface, and it's bent. And this is usually what happens when there is refraction. Not always. There is one special situation where it doesn't happen, but most of the time you're going to get this kind of bending. You won't get it if A and B have the same index of refraction. Okay? You won't get in that situation. You also won't get it if it's fired straight on. So if it came straight down, there wouldn't be any deflection. But otherwise, there's deflection. As I was just saying a moment ago, these angles are measured relative to the normal. So theta A is right there. That's what this green line is, by the way. It's the normal. It's perpendicular to the interface. And so that's theta A there. And down here, this angle here is theta B. Now, in this particular example that I've got, theta B is clearly greater than theta A. In this example, it doesn't always have to be that way. That's just how it is here. Well, based on that, in this formula, the bigger the angle is, and of course my angle can only be between 0 and 90, so in that range, the bigger the angle is, the bigger the sine is. So that means this here is bigger than this. Well, in order for this equality to hold, that must mean that in B is going to be less than, I totally drew that wrong. Let's try that again. There we go. In B is going to be less than in A to maintain this equality in this situation. But this is the law of refraction. Now, I've been talking about as if the light ray were going from A to B, but it could be going from B to A, in which case it would follow the same path that I've drawn. Nothing would change because it has to obey Snell's law.